Today we're going to be looking at solving rational inequalities. Well, let's put those two words together. We have rational and we have an inequality. Rational means it can be written as a fraction, and inequality means obviously it's not equal, right? So you could have less than or greater than, or less than or equal to, or greater than or equal to. Putting that together, it will contain a variable in the denominator. So that is one thing to point about rational. Not only is it going to involve a fraction, but that fraction will have a variable in the denominator, as we can see in this example. And it will have an inequality sign. In this case, it's greater than or equal to. So let's read this example together. 6 over x minus 2, the quantity is greater than or equal to negative 4. So we have a rational inequality. We have an inequality sign, and we have a variable in the denominator. You see that, and you're going to follow these steps in order to get to the right answer. So let's learn those steps. Step 1 is to move everything to one side. I do mean everything, so I'm going to go ahead and underline that. So notice how the minus 4, we're going to add 4 to both sides. In fact, I will show that. I know a lot of students like to just see every step. So we want to move that 4 over to the left, because we want everything on one side. If you do it correctly, you'll have 0 on the other side. And I would recommend, for convention, although it doesn't really matter, move everything to the left and have a 0 on the right. So now we have 6 over x minus 2 plus 4 is greater than or equal to 0. Perfect. We've completed step 1. Step 2, we're going to combine expressions. So notice we have to combine this expression with plus 4. They need a common denominator, so I'm going to have to write 4 over 1. And x minus 2 is not the same as 1, right? So I want to basically turn the 1 into an x minus 2. So I have to multiply it by x minus 2. And since I'm multiplying the bottom by x minus 2, I have to multiply the top by x minus 2. Because then ultimately I'm just multiplying by 1, right? So when we do that, let's be careful here, folks. We have a common denominator of x minus 2. So all this can become one denominator of x minus 2. And now my numerator is going to be what? 6 plus 4 times x minus 2. Just like that. So what I'm going to do now, I'm going to distribute that 4. I like to show things when I can, so I'm going to multiply the 4 into both of those. And I'm going to have 4x minus 2 times 4, which is 4x minus 8. Really showed at that time. And I have a 6 over here, so obviously what we can do now is combine the 6 with the minus 8, which becomes minus 2, and the 4x stays the same. So now we have 4x minus 2 over x minus 2 is greater than or equal to 0. So now what? Well, remember folks, we're trying to solve for x. Right now we're having an issue here because we have an x in the numerator and denominator, and that's going to be hard to get it by itself. So fortunately, we get some little tricks we can pull to make this work. Set the numerator equal to 0 and solve for the variable. So this is not going to give you the answer, right? What we're doing is we're taking this right here and setting it equal to 0, but it's going to give you a test value. We'll see that in just a second, but just note that step 4 is not the final step. Again, step 4, though, is to set the numerator equal to 0 and solve for the variable. The reason for that, we have a 0 here, right? So if we set this equal to 0, this is going to give us a hint as what the answer could be. So we're going to add 2 to both sides, then we're going to divide by 4, and we get x is equal to 2 over 4. So x is equal to 1/2. So that is our number we're going to take a look at, right? Remember, this is an inequality. So we know x is not equal to just one number, right? It could be lots of numbers. For example, the answer could be x is greater than 7 or something. So anyway, just to be clear, that's not the solution. It's a test value. Next step, we're going to set the denominator equal to 0 and solve for the variable. Again, this is actually also a test value. This number right here, when it's equal to 0, will influence the answer, right? Because we know that the bottom can't be 0, but however, it could be bigger than 0. So if I plugged in 3, it would work, right? And if I plugged in 2, won't work, but 1 would also work. So 2 is going to give me a hint as to what the answer could be, which is why we're doing step 5. So set the denominator equal to 0 Add 2 to both sides, we get x is equal to 2. That's another test value. Step 6, place the variables on the number line. Sorry, variable values. So what did we figure out? First test value was x equals 1/2. Next one was x equals 2. We're going to put x equals 1/2 and x equals 2 on the number line. Notice how they are solid points. Step 7, choose test values for each interval on the number line. By the way, yeah, we know that our answer is going to have solid points on the number line because why? Because this is greater than or equal to, indicating a solid point. Anyway, so step 6, place the variable values on the number line. Step 7, choose test values for each interval on the number line. Well, any number to the left of 1/2 will work. 0 is easy. Any number between 1/2 and 2 will work. We'll pick 1. Any number bigger than 2 will work. Let's pick 3. Step 8, plug test values into the original inequality. So if you recall the original inequality, let's go back here real quick. Have to go all the way back, is right here. So we're plugging our test values on the number line into x. So I did kind of misspeak earlier. These are not test values. These are kind of those numbers that you saw for. They're kind of like they're markers on the number line. The numbers in between and on the outside, those are your test values. Okay, so just clarifying that. So we're plugging those into the original. We're going to plug in 0 for x. We're going to plug in 1 for x. We're going to plug in 3 for x. Those test values we chose around our marker values. Step 9, check the validity of each test value. So what do we get for the first one? We get 6 over -2, which equals -3. And this is funny, guys. Actually, that is greater than -4. -3 is bigger than -4. Think about it. So that actually works. So when we plugged in 2, it worked. Keep that in mind. Or I'm sorry, when we plug in 0. Let's be clear here. Yeah, that was our first test value, 0. Okay, what happens when we plug in 1? We get 1 minus 2 is -1. Is -6 greater than -4? No, so it won't work. Final test value was 3. We plug that in, we get 1. 6 over 1 is 6. Is that bigger than -4? Yes. So what that means is when we plugged in 0 and 3, they worked. When we plugged in 1, it didn't. What that means is this part of the number line is going to be shady because 0 worked, and this part of the number line is going to be shady because 3 worked. This will not, because when we plugged in 1, it didn't work. Step 10, shade the sections of the number line in which the test values were valid. And so there you go. This is the answer to our inequality on the number line. Any number less than or equal to 1/2, and any number bigger than or equal to 2, and I do have to actually make a 1 second here. Yep, here's the one thing I gotta fix. Mr. Underwood, I must have made a mistake. 2 will not work, right? 2 will not work because it can't be 0 in the denominator. So what we have to do here, folks, with our final answer, see how this is a solid point at 2? That cannot be. It must be a whole. X cannot be equal to 2. Therefore, we're going to take the bar out right there. And you know, actually, when I made the number line originally, I should have put a hole there, knowing that x cannot be equal to 2 because it's in the denominator. The other test value 1/2 was in the numerator, so I don't have to put a hole there. And regardless, I want to say one more thing before we wrap up this example, and I'm glad I caught it. Regardless of the original sign right here, that will always be the case. There'll be a hole there whenever the denominator is equal to 0. Now, for that numerator, we can keep a solid point because of this sign. But for the denominator, we have to make a hole there. So let's go back to our final answer. And this is it, folks. X is less than or equal to 1/2, or x is greater than 2, and that's step 11, which is to write out the solution. There is a word here, union, which means when you put the answers together. Now sometimes there's going to be overlapping on the number line and stuff, and in that case you have to phrase your answer differently. But in this case, it's either x is less than or equal to 1/2 or x is greater than 2. That's your final answer. That's it for this one. If you have any other questions about it, let me know.